So I know this looks like a lot of code, but I'm going to walk through it little by little. And hopefully each step will make sense. So the first step is just this one line of code. What does this do? This is not a trick question. This should be a relatively easy line of code to interpret based on the things that we've talked about today. You have to know what the equal sign does and what the dollar sign does. Does anyone have a guess? Yeah, great. So I took the gender data out of the data set and I've made a copy of it and named it plotting colors. Why would I do that? That's kind of silly. Plotting colors just has M's and F's in it now. Those aren't very useful plotting colors, but I'm going to change those values in a minute. But to start out, I'm just creating a new variable called plotting colors and making it a copy of the gender variable from the data set. Remember, this is the data set. The gender variable is one column. There's 20 values in it. And the first 10 are M and the second 10 are F, but they could be mixed up, not in order like that. And this would still work. So that line is easy. The next line is a little more complicated. Plotting colors was all these M's and F's before, but here I've done something to change it. What have I done? This is more complicated, but does anyone have a guess about what this does? Yeah, that's exactly what it does. So it takes the variable plotting colors. It finds which of those values correspond to the rows in the data set where gender is equal to F. And it changes those values of plotting colors to green from whatever they were before. Plotting colors was just a copy of gender. So those values of plotting colors were F before, but now instead of F, they're going to be green. So now plotting colors has 10 M's followed by 10 greens. So we are on track to where we want to be, but not quite there yet. The next line does this. It's exactly the same as the previous line, except it changes the values of plotting colors such that the gender variable in the data frame is equal to M, and it changes them to blue instead of green. Now plotting colors is a vector of length 20, some of the values of which say blue and some of which say green. So each piece of this, it's useful to have a technical understanding of what each piece of this is doing, but long story short, these 3 lines of code basically make a copy of the gender variable, call it plotting colors, and then change all the F's to green and all the M's to blue. So now plotting colors is just a set of colors that we might want to use to plot some data. And then I'm going to plot that data. I'm going to run this plot function, show you the resulting plot over here, and then explain the arguments to the function. Plotting functions often have a lot of arguments, but they're often all optional. And so each of these just tweaks the appearance of this plot a little bit, and I'll explain what each one does. So plot is this generic plotting function, and score tilde age, well, that's the same thing we plotted before up here, right? It makes a scatter plot where score is on the y-axis and age is on the x-axis. And when I did it up here, we got this plot. And that's pretty cool. It has these circles as the individual observations. But here I'm trying to show you maybe a slightly nicer looking version of it. So the first argument, score tilde age, specifies which variables to use. And it matches the syntax for the regression model, where score, being the response variable, is plotted on the y-axis, and age, being the predictor variable or independent variable, is plotted on the x-axis or horizontal axis. And both of those are coming from the data set known as DAT. That you saw before. And there are 3 new arguments that you haven't seen yet. The first one, PCH equals 16, looks very cryptic. PCH just stands for plotting character. And there are many plotting characters to choose from, and they all have numbers. So rather than trying to memorize them, you could just experiment. You could see what plotting character 1 looks like, and 2, and so forth. Run the line of code over and over again with different ones, and see what you get. There'll be triangles and squares and so forth. The default one is those open circles that are empty in the middle. 16 is closed circles that are filled in. So that's why I changed PCH from the default to this 16. The next argument, ylim, it takes a vector as its input. And that, I suppose, is slightly confusing, but this is one argument to the function. The argument is another function, the C function, which creates a vector, which we've used several times before. And there's only two elements in that vector, 0 and 10. I'm plugging them both into ylim, because ylim is the argument that defines the limits of the y-axis, and the two values of the vector are supposed to be the bottom and the top. So I told it to show the range from 0 to 10. Before, it was not showing 0. And so the only point of this is to make the y-axis a little prettier, a little more comprehensive by showing the full range of possible scores. Maybe this is some kind of test with 10 questions on it or something. And the final argument, COL, stands for color. And it gives the color, well, let's show what happens if I do COL equals red. All the points are red. So you can provide one color, and it will just make all the points that color. But you can also provide a vector of the colors of all the points in order that you want it to plot. And plotting colors, we just got through creating it. It is that vector. It has green for all of the female participants and blue for all of the male participants. So by plotting it this way, I get a scatter plot with age and score, but it's color-coded by gender. So I can see that, yeah, the women are a little bit older than the men in this sample. They're plotted in green. But that's clearly not the reason why the scores get higher as age goes up, or at least it doesn't seem to be the reason why. Instead, it seems like there is a relationship between score and age in both of the gender categories that we have available in this data set. So already this is a slightly more informative plot than the previous scatter plot. But of course, I can add the AB line from before too. AB line is just a function that draws a line. And the easiest way to use this function is to plug in a regression model as its argument. Score age regression is this thing that we made up here, right? Score age regression was the result of using the regression function with score tilde age as its argument. So that will draw that best fit line computed by that regression model. When I say best fit line, this is the line that comes closest to all the points. Obviously, if you could draw a squiggly line, you could get it through all the points, but we're saying it has to be a straight line, but we want to pick the straight line that comes as close as possible to all of the points without breaking the rule that it has to be straight. That's what linear regression is. It's a solution to that particular math problem of finding a straight line that comes closest to all the points. Closest in the sense that it minimizes the sum of the squares of the distances from the line, but it's okay if you don't always remember that aspect of it. And I want to add one more element to this plot. So far, I hope this plot makes sense. I'm going to add one more element using this legend function. I don't want that to confuse you, though. You don't have to do that, right? You don't have to do any of these things in order to get a plot that's useful to you. But I want to show you that you can build up a plot piece by piece by adding little bits to it. And so here I've got this color-coded plot. Maybe I want a legend showing what those colors mean. So the legend function, just like the AB line function adds a line to a plot that already exists, the legend function adds a legend to a plot that already exists. The legend function looks intimidating at first because I've provided 5 arguments here, but it's not that bad. The first argument is the x coordinate of the legend. It needs to put the legend somewhere, so I've got to tell it where to put it. And I'm just going to put it in the corner down here because there's no points down there. So that space is available for me to use for a legend. So 45, I can see it right here on the x-axis. I want the legend to be somewhere around there. And 2, that's where on the y-axis the legend is going to be. So 45 and 2 are like right where my mouse is pointing now, and that's where I want it to draw the legend. And the third argument to legend specifies the text that I want to include in the legend. And so that I'm just using the string women and the string men to designate the two gender groups that I have in this sample of 20 participants. Those three arguments, I did not provide the name of the argument. Remember that when you call a function, you can provide the arguments in order, or you can provide them by name. And sometimes it's useful to do a combination of both. Like up here with lm, the first argument was just this formula, and we didn't give it a name. But then data is not necessarily the second argument, but I can just tell R that I want to provide the data argument next, no matter what order it's expecting them in. So the first three are in order for the legend function. But then after that, I'm giving them all names. PCH is 16 matches the plotting character we used in the plot up here. I want the legend to show the same filled in circles that are in the plot. And then finally, COL, that's color, just like in the plotting function up here, which I'll take the spaces out now that you've seen that argument. And this color argument has two values in it, green and blue, that are in the same order as the text that I want to display. All this together gives me a nice little legend that has a green circle with the label women and a blue circle with the label men. Because green and women were first and blue and men were first in those two respective arguments. And so it knows to put them in that order in the legend. And I could show someone this plot, and at this point, with the legend and the color coding and the line of best fit and the axis labels that were provided by default, which are just the names of my variables, I think that I could show this to someone without much explanation and they could understand what it's trying to get at, even though it contains a fair amount of information. And I also don't think it was that hard to put together, although I had to do some preparation work in order to get my plotting colors the way that I wanted them.